So let's start solving this problem using dynamic programming bottom-up approach. We'll take the same example as numRows is equal to 5. We put it here. So, okay, I'll start with dp1 and dp2 and all. And we have to calculate the final solution as dp5. So as we know that the base case dp of 1 is 1 as given in this example, right? So we start with 1. Now for dp2, as we discussed in our previous video that this first digit has come, that if we have got, let me draw it again. So this first digit has come if we have got an imaginary 0 here, right? And this 0 plus 1, which is this digit. Similarly for this one has come from this plus if we have an imaginary 0 here. So this is how we came up with this. So let's do the same thing here. Let me revert it and go back to my Excel. And yeah. So here, if I just put an if, so I will let me make me better a little bit. So 1, this is the one we have already got 1. And suppose I create an imaginary 0 here and imaginary 0 here as well. Then this becomes, so the first digit would be 0 plus 1. So it would be 1. And similarly, the second digit would be 1 plus 0, which is 1 again. So these are the two Pascal triangles that we have created. And I will mark this as well and this as well. Okay. If I use the same trick for dp3, the trick is that if I just add a 0 here first and a 0 here, then dp3 would be exactly same. For the 3 digits that we are going to calculate, it would be 0 plus 1. This is the first digit for dp3. Similarly, 1 plus 1, it would be 2. And 1 plus 0 would be 1 again. And then we have exhausted all the things. So this is our final dp3. This array can represent the final dp for 3 Pascal triangle. So again, I will mark this as this. And okay, guys, so now let's have the basic principles or the paradigm of bottom-up approach, right? So we start with the base case first, and then we try to reduce, the numbers by ourselves. And once we move to the upper level, we try to see that whether we are able to, so we have to do two things, right? First thing is that whether we are able to reuse the solutions that we have already solved in the previous subproblem. For example, in dp3, we have seen that we are using the value from dp2 because we are adding these numbers and then finally getting the digits for dp3. So first thing is already done. We are reusing the solutions which we have already calculated. Now, the second most important part is that whether we can deduce any algorithm out of it, right? So this algorithm would be common for the remaining higher level cases. So here the formula is very simple, right? If we maintain, like say, 2 pointers, right, to I and j, for example, see. So once I have calculated dp1, say only with the base case 1, we already know that. And when we move to dp2, so we added 0 and 0 here as the prefix and the suffix for dp1. So here, if I create this 2 variables I and j, and suppose for dp2, say this is I, okay, and this is j. This is j. So this number that we get 1, this is I plus j, right? 0 plus 1. Then we move both these 2 pointers I and j one each. So this becomes I, and this becomes j, right? So this is how we are shifting this, and we are coming to a common paradigm or an algorithm, which I can say. So once we have this as I and j again after shifting, So this value comes from I plus j again, right? So this is, we start with, again, let me reiterate this. If I start with I is equal to 0 and j is equal to 0, after we append 0 at both the front and the end of the previous DP subproblem, and we start with I is j is equal to 1, right? So we start with I is equal to and whatever the numbers that we are going to calculate. For example, for the very first element of DP of say the row that is created for 0 is equal to the previous row that was there, that is row. So this becomes, for any element in the next row, the row previous of I plus row previous of j, and we start with 0 and 1 until we exhaust all the numbers that we have created, including zeros that we have appended. So this becomes our final algorithm or the formula. And then we both increment I plus plus as well as j plus plus, and then we fill all those elements for a particular DP row, and then we move to the next one. For DP3, again the same formula applies. Once we append 0 and 0 here at the ends of DP2, and we apply the same formula here. We take the row previous of I, starting with 0 and 1. So I is 0 and j is 1 here. So this particular element we got from row previous I, that is 0 plus 1. We got this number, and then we increment both I plus plus and j, I and j. So here again, I is pointing to this, j is pointing to this. So this element becomes 1 plus 1. That is row previous of I plus row previous of j, and so on until we exhaust all the numbers in the previous DP. So just using this formula, let's quickly fill in for all DP5, and then we will deduce this algorithm that we have done in Java and submit it in LeetCode. So let me quickly fill this first before we move on to IntelliJ and solve this problem using the algorithm that we have just created. So again, this would be 1 plus 0, so it would be 1. 1 plus 2 is 3. 2 plus 1 is 3 again, and 1 plus 0, 1. This becomes our formula for DP4. Again, we append 0 here, 0 here, and finally our DP5. This is our final row. So again, we start with I is equal to 0 and j is equal to 1. And so I is equal to 0 is this, j is equal to 1 is this. 1 plus 0 is 1. Then we increment both I and j. So I becomes this, I is equal to becomes 1 and j becomes 3. So 3 plus 1, 4. And then similarly, then again I and j are incremented, which gives me a result of 6, and then 4, and then 1. So this is my Pascal triangle for row number 5. Okay, so this was all the formula about, and this was like bottom-up approach. We started with the base case with 1, and we actually added 0 whenever we move to the next DP calculation, and then we use this formula. We use these 2 pointers I and j, starting with I is equal to 0 and j is equal to 1, and we simply add the previous elements, the previous row elements for I and j, and increment I and j, and then come up with the final numbers or solutions for a particular DP Pascal triangle. So in the next video, we will solve the same problem, the same algorithm that we have deduced here in Java, and submit in LeetCode. So see you all in the next video.